So hopefully everybody is right here. It says variation within a data set, Common Core algebra. Thank you, dear. Common Core algebra 1. So variation within a data set. Measures of central tendency. We already learned those. Let's just write up top what they are. What are my measures of central tendencies? Y'all remember? Mean, median, it is mode, and there's one more, range. Those are our measures of central tendency. Measures of central tendency. Mean, median, mode, and range. Okay. So we use those, and that gives us some valuable information about a data set, but it doesn't give us everything that we need about a data set. It doesn't give us everything that we need. So it doesn't tell us about variation, right? It doesn't tell us about the variation within the data set. So two data sets can have the same mean or the same median and look radically different, okay? So we're going to learn about two different tools that let us kind of see variation within the data set. So the first tool that we use is called the interquartile range. So I have a question. What graphic representation shows us quartiles? We did these yesterday. What graphic representation shows us quartiles? Say again. Yeah, the one with the whiskers. It's the box and whisker plot. Okay. So when you're asked about an interquartile range, that means you want to have a box and whisker plot, or you're going to have to calculate some numbers. Well, it tells you right here that the interquartile range is the difference between Q3 and Q1. So if I want to find the interquartile range, come on, pen. I just take Q3 and I subtract it from Q1. So I'm not going to use Desmos because we know how to look at the data set and find Q3 and Q1. But if you forget how to find Q3 and Q1, you can always use Desmos and make a box plot. So that's why I want you to know that. So we're gonna just do it the old way. We're going to find the median. Then we're going to find Q1 and we're going to find Q3. And then we'll find the IQR. So what is the median of this data set? The middle. Well, remember, you can do this. Take one from the bottom and one from the top. Or you can count how many points there are in the data set and divide it by 2. One from the bottom, one from the top, one from the bottom, one from the top. Did everybody get 7 as my median? Yes. Middle number is 7. So now I'm looking for the middle of the lower half. So there are 1, 2, 3, 4, 5, 6, 7, 8 numbers in the lower half. So I know the middle is happening right here. What is the number that's right in between 4 and 5? Say again. 4.5. Yeah. How did I find that? I took 4 plus 5 and I divided it by 2. Okay. Let's go to the top half of our numbers. 1, 2, 3, 4, and find the middle. Right there. What's the number that's right in between 9 and 10? 9.5. So if I want to find my IQR, my interquartile range, I'm going to take Q3 minus Q1. 9.5 minus 4.5. And that gives me 5. So my IQR is 5. Okay. Now let's look at the next set of data. The next set. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 points. So I'm going to put 5 on each side. So the median is what? It's 7. Notice that we have the same medians for both of our data sets. We have the same median for both of our data sets. Let's find Q1. 1, 2, 3, 4, 5. So the middle is 6. Let's find Q3. What's the middle number of that upper half? 8. Yeah, 8 is right in the middle. Remember, if you don't understand that or you don't like that method, you can just take 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, okay? So my IQR, interquartile range, Q3 minus Q1, which is 2. So this has an interquartile range of 2. So do you think that there's more variability, more of a spread in the first data set or the second data set? And remember that that IQR is representing the box. It's representing the box. That's what Q1 and Q3 are. It's the beginning and the end of the box. So if there is more spread in the box, that means that the IQR is bigger. If there's less spread in the box, that means that the IQR is smaller. So here's a way to represent variability. Data set number 1 has more variability or more spread of data than data set number 2. Does that make sense? So what does that number really mean? It means that data set number 1 has an IQR of 5. It means that all of the numbers in the box are within 5 points of each other. If I were to count, to go from 5 to 9, 5, 6, 7, 8, 9. Oh my gosh, they are. Let's look at the second one. All of the points within the box are 2 points away from each other. 6, 7, 8. The difference is 8. Okay. Are we the difference is 2. Do we understand that? Okay. So let's look at standard deviation. So standard deviation is another way that we actually, and it's a better way, it gives us a really accurate piece of information that we can calculate variability. Yesterday, when I gave you your green sheets, so you should probably get those out. When I gave you your green sheets, pull out your green sheet from yesterday. We had I wrote standard deviation on there 2 times. We had 2 types of standard deviation. The first one was standard deviation of the sample, and the second one was standard deviation of your population. Okay? So, standard deviation of your population looks like this on your calculator. It's this symbol if you see it. This is the standard deviation of your population. And if we want to find the standard deviation of our population, what does your green sheet say we need to use? Standard deviation of your population. What does it say on the green sheet? What are we typing into Desmos? DEVP, is that what you said? Yes. Standard deviation for the population, we have to put a P on the end of it. If we want to find the standard deviation of a sample, which is what we're going to do on the next page, the sample is this symbol in your calculator, and we just type in STDEV into Desmos. So I wanted to make sure you see that. You see that on your green sheet. It's on your green sheet. The population is the last one. The sample is the first one. And I didn't put the symbols on there, and you probably need those. So I would add this on your green sheet. I would add this symbol for population, and I would add this symbol for sample. Because sometimes it might not say sample. Sometimes it might just give you that. So for population, for sample, put the S, the population, do that data. Okay. You guys see what I'm asking you to do on your green sheet? Write the symbols so you know. So here's your sample. So S with a little X next to it, little envelope. And then here's that cursive O. Yep. I want you to be able to recognize the symbols. Did you get them? So put S of X here. S with a little X, like I wrote up there. And then population is a cursive O with a little X. So S of X, just write right here. I want you to recognize it with a little X. And this is a cursive O, thank you, ma'am. Cursive O with an X. Is everybody seeing what I want them to write down? I want you to know the difference. So population, O of X, sample S. Let's see where you put it. I can't see it. On the calculator. So we go to stats. We're going to go to calculator, one variable statistics. We go down to calculate. He has to have a table built first. Okay. So I'm going to just edit a list. I'm going to just put it in 7, 8, 9. Okay. So I've got a data set. So now I'm going to go to stats. I'm going to go to calculator, one variable, enter, list 1. So I just put data in there. Calculate. So O sub X is population. S sub X is sample. Okay. You see how they're different? They're not the same number. Okay. All right. So let's keep going. So the standard deviation tells us how far away from the mean a data point is. So the larger the standard deviation, the greater the variation. This is what I want you to know. The larger the standard deviation, the greater the variation is within the data set. Okay. So a farm is studying the weight of baby chicks after 1 week of growth. They have their weight in ounces of 20 chicks listed below. We're going to find the mean, the interquartile range, and the standard deviation. Okay. So I'm going to build this data set in Desmos. You can build this in Desmos or on your calculator. You can do it in Desmos or on your calculator. Thank you, ma'am. All right, so if someone feels like they can maybe shout out some numbers to me, I'm going to call this data set capital C for chicks. Will, you going to shout out some numbers for me? I got 2, 1. Go.
2, 1.
Yep.
3.
Yep.
4.
Yep.
2.
Yep.
2.
Yep.
3.
Yep.
1.
Yep.
5. 3. 4. 4. 5. 6. 3. 8. 5. 4. 6. 3.
Dang, that was fast. Okay. So 20 elements. Whew, we got our data set in there. The first thing that I need to find is my mean. That's what it's asking me for. It says I want the mean. How do I do that? How do I find the mean of a set? It's on your green sheet. How do we do that? Do not say add them all up. How do we do that? It's the average. How do I find it? What does it say on the green sheet? Type in the words MEAN, the letters mean, and name your set. Don't add all that up. Let the calculator do it for you. What is our mean? It's 3.7. Yeah, this is 3.7. So I'm going to go to my notes. I'm going to write out that my mean is 3.7. Whoops, let's change our pen. 3.7. And we're talking about the weight. So it's 3.7 ounces, meaning that the average weight of a 1 week old chick, baby chicken, is, so if that baby chicken is a week old, the average weight is 3.5 ounces. That's what that's telling me. The next thing I need is the interquartile range. Let's see. That's the Q3 minus the Q1. How am I going to get that information? If I want quartiles, how am I going to get that information? What graphic feature gives me quartiles? A box plot. So I'm going to type in the word box plot, capital C. And now I need to look at my box plot. So I need to kind of scroll over to where my box plot lives. I'm going to make it a little bit bigger so we can see some numbers here, possibly. Okay, maybe not. Maybe my box plot is, I have to just do this for a second. Sorry, guys. Okay, so where's our box plot? Did it disappear? Okay, let's just try it all again. I know, it's so much fun. Sometimes I just want to scream with the technology. So we don't have anything. Height of 1, nothing.
I saw it. I know it was there.
I know it was there. Okay, well, I'm just going to give you the information from the notes. Sorry, guys. No box plot picture. You're just going to have to trust me. So the interquartile range Q1 is 2.5 and Q3 is 5. So we're going to take 5 minus 2.5. So that means that my IQR, my interquartile range, is 2.5 ounces. Remember, this is the box. This is everything that's in the box. That's what that's representing. Everything in the box. 2.5 ounces. Okay. So now let's talk about standard deviation. STDEV. I'm doing a population. I'm using that theta symbol, standard deviation of the population. So it says that my standard deviation, if I round it to the nearest tenth, is 1.7. 1.7. So 1.7 ounces. So I just want to talk about what that means. If the average is 1 standard deviation from the mean, that's how we say it. It's 1 standard deviation from the mean. Well, that means that we take our mean weight and we add the 1.7 ounces, and we take our mean weight and we subtract the 1.7 ounces. So that means that a baby chick, an average 1-week-old baby chick, that's 1 standard deviation from the mean, is in between the weight of 2 ounces on the small side or 5.4 ounces on the large side. That's how we use a standard deviation. It also tells us about the variability. This means that the data is pretty close. 1 standard deviation, 1.7 ounces. So most of those chickens, almost all of the chickens that were up there were between the weight of 2 and 5.4 ounces. There were only 3 of them that didn't fall within that range. Okay. So let's go to the next page. So our next one is talking about samples. We have a sample of data. So a marketing company is trying to decide how their soda product reaches a specific age range of people. So they have 2 soft drinks. They pull a sample of people and they say, hey, do you like soda A or soda B better? They want to have a more diverse age range, meaning they want the standard deviation to be greater. They want a greater standard deviation. Why? Because the more diverse their range is, the more people that they reach with their soda, right? The larger the soda population or the diversity, the more people that they reach. So the first question says, why is standard deviation a better measure of diversity? And so we're going to say that standard, and I just abbreviate it, standard deviation measures, are you guys with me? It measures variation. So if we're looking for a diverse age group, that just means that the larger the standard deviation, the more range in my age group. You don't want to create a soda that only appeals to people from the ages of 15 to 20. You want your soda to appeal to all different types of ages. So looking at the two data sets, soda A or soda B, Olivia, pick your head up for me. Soda A or soda B, which age group or which soda do you believe appeals to a larger age range? Why do you say that? Say again. It goes up to 40. What's the range? What's the range in the ages of people that like soda A? What's the youngest person? What is the youngest person? 16. What's the oldest person? 44. So if I were to find the range, 44 minus 16 is what? 28. So there's a age range of 28. So that means that the diversity has a 28-year age range for that soda A, the people that like it. What about soda B? How many people like soda B? What's the oldest person that enjoys soda B? 30. Yep. What's the youngest person that likes soda B? 18. What's the age range there? 12. So which one do you think appeals to a more diverse crowd? Soda A. We just did that using the range. Let's figure out the sample standard deviation for soda A. So that means I have to go back to Desmos, and I'm going to input this data set for soda A. So A equals 18. Does anyone want to, can someone yell these out so I can type them a little faster? 18, 16, 22. Yep. Yep. Okay.
38, 22, 29, 25, 44, 36, 27.
So after 44, 36, I didn't get the last 30. Okay. So we want the sample standard deviation, STDEV, of this set. And we get 9. If we round to the nearest 10th, what do we get? About 9.1. So soda A has a standard deviation of 9.1. Okay. Let's figure out the standard deviation for soda B. It'll come back up in a second. Soda B, who's going to rattle them off for me? 25. Yep.
27, 19, 22, 28, 25, 19, 23, 29, 26, 18.
Okay. So in this set of soda lovers, my standard deviation is what? 4.1. Which one has a greater standard deviation? Yeah. So the standard deviation of soda B is 4.1. So we said that soda A reached a more diverse age group, and we just proved it. It has a greater standard deviation. It has a greater standard deviation. Okay. All right. So population versus sample standard deviation. When we're working with every possible data point that's given, we call that population standard deviation. But when we only have a sample, we use the sample standard deviation. So which of the following data sets would have a standard deviation closest to 0? So remember that if the standard deviation is close to 0, there's hardly any variation in the data set, hardly any variability. Which data set up there has the least amount of variability? Say it again. 3. Why did you choose 3? So it has a range of 2? Yeah. What about data set number 1? What's the range there? Yeah, it has a range of 10. What about data set number 2? It has a range of 15. And what about data set number 4? Yeah. So without even looking at standard deviation, we can probably use the range to identify which one has the least amount of variability. But when it comes to having the greatest variability, especially with larger data sets, we're going to have to let standard deviation calculate that for us, okay?